Yes, excellent. First things worked. Yeah, I'm Tim Panton, Steely Glint, and what I want to talk about is adding the web bit in RTC, WebRTC. You're all RTC experts, but I feel like maybe a little bit more web might be good. So that's what I'm going to talk about. I am, shocked at what's happened to my slides. Right. Well, anyway, my business card says I'm a protocol droid, which basically means that I'm both interested in implementing protocols, but I'm also interested in explaining tech to other people. So it's both of C3PO's roles. I'm interested in WebRTC evangelist, so I push standards in the WebRTC world, but also push WebRTC to other people and introduce them to it. And currently I'm consulting at Wire.com. Wire takes no responsibility for anything I'm about to say, but they've been kind enough to let me use some of the stuff for demos. So, yeah, that slide came out wrong. Right, so I claim that in like 1905, physics was pretty much totally understood. And I actually said this a couple of years ago, and it's just as true now as it was then. So 1905, physics was pretty much understood. Everyone understood that Newtonian mechanics pretty much covered everything you wanted to do in physics, and it was a done deal. There was really not a lot new to do. But there were a couple of minor details that didn't quite fit the model. One of them was the photoelectric effect. And this guy went off and did some investigation into the photoelectric effect. And the result of that was that actually, whoa, there's a quantum universe there. Things aren't quite what they seemed. First approximation, they are, but if you dig a bit deeper, you find that there's a whole lot of interesting quantum possibilities there. And we've spent the last 110 years exploring them, and we've come out with a whole lot of new things. Basically, computing is a derivative of the quantum universe, and there are other factors. So my claim, and it's a big claim, is that WebRTC is like that. It's the tip of an iceberg in redoing communications, real-time communications, in a different set of ways. I think it offers us the opportunity to change the communications baseline. It's a big claim, but I think it's arguable at least. So this is the old way. We ran into this last night. It was funny, 4 of us sitting around a table, and totally unaware of the fact that this gorgeous telephone was behind us. And then as we walked out, we spotted this delightful thing. It's a payphone. It's the classic thing. It's you pay for minutes to make a call. But WebRTC is not like that. I heard this week that Twilio are proposing to do 1 billion WebRTC minutes this year. And most of them will be inside apps of either web apps or like Twiddler, or Uber. So Twiddler is an online whiteboard. I've got a little thing there. And basically, you can't see it, but the orangey button allows you to press that and put you into a conference call with all of the other people who are currently editing that workspace. So it's a chat thing, it's a voice chat thing, but it's actually around the document. And likewise with Uber, the conversation isn't around the call, the conversation is around getting me from A to B. So the context is the critical thing. What you're trying to achieve, what you're trying to do, as opposed to the call. So the first thing you do is the context. The second thing is the call is a way to resolve the issue or help you communicate. So the lesson from that is, in particular in the web, is don't underestimate what you can do with JavaScript. You can use cookies and stuff to combine the contexts, to pull your experience together. But there are also some fantastic tools that some of you may not be totally aware of. Things like WebGL and WebAudio that you can plug into WebRTC and bring up a much richer experience. So talking about context, essentially setting up a call is about establishing a shared context. So it's somehow James and I need to find some way of getting ourselves plugged together in one way or another in order to set this call up. Phone numbers is one way of doing it, and that resolves the who am I. It doesn't resolve the who can I call, because phone numbers are a flat space with no basic restrictions. It's a federation, but with no buddy lists in effect. And do I want you to, do I want to speak to you or not? Again, phone numbers don't address that in any sensible way. You need a buddy list or block lists or whatever to try and address that. So if you look at the way that that works on the web typically now, and also on classic SIP, basically you log into something and you use that, and you set a cookie or a token or something, and that preserves over the session. There are other ways. I mean, I think the classic one that most of us do now without really realizing it is to set up a text chat first, so a Skype chat or something, and then at the point when the discussion in text becomes too complicated or unsatisfactory in some way, we then upgrade it into voice. So we've already got the established context, and then we upgrade it into voice. If you look at one of the ways that's new, and I think is quite interesting, it seems totally trivial, but it's actually addressing a really clever problem, really interestingly, which is appear in, just use the URL as a rendezvous point. So anyone else who browses to that URL now will join into my video chat room, which I think is quite an interesting. Ooh, I can't change the volume. That's interesting. So, I mean, if anyone chose to do that, you could join in. I don't know if you want to or not, but oh yeah, somebody's trying to. And there we go. So that's all just done based on a URL. So there's a URL addressing scheme. I've got no control over who joins it, although I could do locking and stuff like that. Right, I think it's time I left before it got out of control in here. They're all pretty unruly, these guys. So you can base it around a URL, but for the particular thing I wanted to do, that wasn't sufficient. I wanted to control access in a much more fine-grained way than that, which is Yopet, which is for video calling my parrot. But I need to tell you a couple of other things first before I can explain that. So I mentioned earlier one of the web techniques that one can use is WebGL. Now WebGL is basically in a complete video suite in your browser. It's a real-time video suite that allows you to apply the kind of effects you've seen on TV onto your browser screens. So again, this is seriously.js, and this is a green screen. So this guy's recorded himself on a green screen, but you can then apply, and this is happening in my browser, I can apply an effect to that. Now that's taking place in my Chrome browser without him having to do anything apart from record himself in a green screen. And it's doing it in real time in my browser. And you can do that, okay, this is a recording, but you can apply that to a WebRTC stream. So you could do this British invasion look to an incoming WebRTC stream if you chose to. Okay, that's kind of cute, but not necessarily stunningly useful. I think it's interesting, actually, but perhaps the other one is rather more exciting or surprising, I find. So this looks like your classic get user media. This is a get user media showing me, and you look at that and you think, okay, I've seen this demo 103 times. And here's a piece of paper, and now I'm going to do a magic trick. So it spots it's using WebGL. I put my hand in and break it. It's using WebGL to analyze the image. It's spotting a thing it's been told to look for, and then it's replacing it with an image. And that could actually replace it with another moving image if you wanted to. So you can insert into your WebRTC stream some arbitrary other thing based on some pattern recognition on the video. Now again, you might wonder whether there's any point in that, and I leave it to your inspiration, frankly, to come up with good use cases for that. But I think the AR, virtual reality type thing, is exactly what that's going to be used for. And I think there's a lot of potential in it, personally. I'm not going to talk about business cases, but there are interesting things you can do with that. Now, James specifically asked me not to do this demo, so I'm not going to. It's I'll explain it anyway. So basically what Yopet's about is trying to validate, pair a couple of endpoints together and allow them to talk exclusively to each other and to nobody else. And what it does is it visually exchanges a token. So you show a QR code, like in the previous demo, show a QR code to a WebRTC page. It captures, they both capture that endpoint and use it as an authenticating point to meet up. Now, what's interesting about the way that I've done it for Yopet, and it's relevant to a couple of the previous talks actually, is that although it's a proximity-based pairing thing like Bluetooth, the choice of the token that we exchange visually actually means that because of the way that A, the token is picked, and B, that the WebRTC security model works, I don't have to trust the federated signaling underneath. If I can do my token exchange in a secure way, i.e. visually by proximity, thereafter, I don't have to trust the federation I can detect if whatever's federated the signaling is intercepting it and replacing the media stream. I can detect that because of the way that WebRTC works. So there's an interesting, and I've actually filed a patent on the token choice, so I'm deliberately not explaining that for those of you in the room who are paranoid about patents. Right, so that's about WebGL. And the next thing is WebAudio. WebAudio basically puts a 1980s synthesizer into your browser. You know, one of those things where you can plug this into that and join them up. That's actually exactly what WebAudio does in a way that is really quite cute. Now, I don't know if the audio is working. Can you capture this, or anybody? No? It's probably, I don't know which one it's coming out of, but...
Probably it uses your HDMI now for audio output. Maybe you can just go to the settings and look for your standard output device. Or sound. No sound. No in the settings menu.
I think that might...
It's so big. No, trust me.
Alt with that.
Well, but that's the same... Oh, okay.
So here you can, you have two.
Well, I could try the HDMI, but I think that's where it was before.
The headphone is the right one.
Okay, so if I put it on headphones, that's there now. No, it's fine. I've got it, yeah, but it's just not, it's not plumbed through. It doesn't matter. Oh, there we go. Cool. So we now have we have a useless synthesizer player, but we have a late 80s synthesizer in our browser. This is entirely running in the browser. Again, you might question how relevant that is to you guys, but well, I don't know. I think it's interesting, and you can modernize that look, and you don't have to have the whole retro thing. You can do. And then decide that actually you want it to sound like you're in a parking garage, and it'll add a load of reverb or I don't know, a cave, and whatever. But so this is all done in the browser. There's no magic to that. There's no remote magic to that. So who cares? Well, actually, you care because you can apply all of those transforms to the WebRTC streams that you've got from local or remote WebRTC devices. So get user media, but also the guy at the other end of your RTP stream. Chrome only does this on outbound WebRTC streams. So I can intercept my microphone, stuff it, put echo on it, whatever, and send it out. But I can't do the same on the way back in. Firefox 39 lets me do the same on the way back in again. So the sorts of things you could do in that processing, I mean, the basic building blocks are things like filters. So you could filter out noise from the environment. You can put delay on it if you choose to. You can obviously do mixing, so you could do some reverb there. You can do an arbitrary thing, which is a fast Fourier transform in there, in JavaScript, right? There's a JavaScript line which adds a fast Fourier transform to this. And as you'll see in a minute, it's actually not very complicated. You can do stuff like analyze it and do spectrum display. You can do pitch shifting. And in fact, you can do arbitrary maths. Again, you end up doing that in JavaScript. And JavaScript floats aren't fantastically quick, so you probably don't want to do too much in that, but you can. And like I say, on Firefox, you can do that both on outbound and inbound. So coming back to the really pragmatic stuff, why do you care? Well, I, as a VoIP engineer, spend my entire life pretending to be completely insane. I talk to myself. I pick a phone up and say, hello, hello. And I've called an echo server, and I want to see if the thing's working. And this is fine when I'm working at home, but I tell you, working in a co-working space and doing that, you get some weird looks. So as we did this at Wire, we put this together such that we built a thing which I can test the round trip of a complete call without actually having to talk to myself, which is a major benefit. It stops me looking insane. Now, let me see if I can... This is the really dangerous bit. I now have to try and... Now, I should emphasize that this isn't production code. You won't... let's do... and as I said, Wire take no responsibility for any of this. This is just test code that I use for my own amusement. It won't be there in the real thing. So, this is Wire, by the way. I don't know if any of you have used it, but you ought to have done. It's cute. So we won't remember that. Oh. What have I done wrong? There we go. So to do this test, basically I have a buddy called PolyParrot that's actually just an echo server. So what we do is we can call this echo server, and I have to remember to mute the... Right. So now we're in a call with the echo server, and if I unmuted it, we'd get HOW. Yeah, there we go. And in fact, this is a really side thing. This is a really sweet thing. In Firefox, it graphs what you're using in terms of the WebAudio resources. So it produces you a nice little picture of how you connected various devices together. And then, what I can now do is I can inject into the call, with a little bit of JavaScript on the JavaScript console, a noise, which plays it down as if it had come from the microphone, out, down the cable, down, out, through, back through PolyParrot, back up, and plays out through the microphone. So I can now do this without pretending to be insane, which is a way of testing like the whole call all the way through without being nuts, which is valuable. And if you're wearing headphones, nobody knows you're doing it. It's completely invisible to other people. Now, right. So the code for that, this is CoffeeScript, which is just kind of JavaScript with less lines and brackets. But essentially all that's doing is it's saying we create an audio context, and then on the audio context we say we want to create a media stream source based on the WebRTC stream, and then we want to create a media stream destination which I can then give to WebRTC, and then I can add, what I do is I connect in between those two, I connect a chain of things that will do the transforms I want to do. I need to play some audio, so I can load into a buffer audio for an MP3 file. Then I have a buffer which I can add into the chain and play it. It's a slightly weird thing in CoffeeScript, you end up writing code backwards. So actually, this is the thing that does the real work, and when it does something, one of these two things happen, and then that causes this to happen. So you kind of have to read it backwards. And this is the real stuff, actually. So this is how you send an audio file. You've got a buffer already. You just make sure you can get hold of it. You disconnect the original audio source. You connect your buffer, and you say, go play. And that's plays it in here. It plays that. That then causes this to play, and then when it finishes, it reconnects you back up to the original microphone. So, and you can do the same thing on remote streams. It's effectively the same deal, but that only works in Firefox. So, and if you do stuff visually, like I said, you've got that thing in Firefox, but there's also a number of visual editors for creating audio chains in WebRTC, in WebAudio. And none of them actually support the WebRTC endpoints, but they're pretty easy to add. So the thing I'm going to do tomorrow, I was going to do it now, but time's running out, and also it didn't work, is extreme case of the thing I was doing with the knock sound. You can actually use it to measure the latency. So if you you inject it at one end, send it out down through the Parrot server and comes back again, and see how long it took to get back. And then the absolute extreme case is take the Parrot server out and use another device, and then use the audio link to bring it back. And so you have the file you sent and a recording that came back, and you can do a time diff on them and work out what the latency is. And say, I don't actually have that working this instant, but I'm hoping in time for the dangerous demos to be able to do that tomorrow. So my overall thesis here, right, is that the web browser has a stunningly rich set of APIs that aren't just obvious visual static HTML. There are some really rich visible stuff in terms of WebGL and audio stuff in terms of WebAudio that you can use to delight your user or amuse them or whatever. Or you can use it to make yourself look slightly more sane and make your life easier. Or you can do both, ideally. So yeah, I'm Steely Glint. I'll be around today. And I want to thank Wire for letting me do that. OK, thank you.
Thank you, Tim. Yes, I agree that we miss a lot of nice-looking views of what you are doing, especially on the server side. So putting a bit more color, say like that, would be important also for end users, but also for support engineers. And we have Mr. Johansson. You have to turn it on?
You have to turn it on. I'm wondering about these APIs for audio processing. Have you measured the latency they add? If I add a number of cool things, how will it affect our conversation? Browser execution in a cell phone versus on your laptop.
It hasn't annoyed me yet. I don't know is the short answer, but I suspect that it's less than the network by a good chunk. What I haven't done is, I think if you did this in something like a low-end Firefox OS browser on a cheap phone, you might find that actually the latency was significant, and then ran a fast Fourier transform on it. But this is audio code, right? This is none of the transforms that we're doing are even close to as complicated as running Opus. So there's no real reason why it should add a great deal of latency. I mean, sure, you can deliberately add it, but there's no intrinsic reason why it should.
Anyone else?
Other questions? Here? No.
James takes his private phone.
My own private microphone, even. You know what, Tim? I have seen so many WebRTC demonstrations of people doing calls to PSTN and all that sort of thing. But there's only one person who consistently shows off what WebRTC is really good about, which is all this other stuff, and that's you. And you are to be congratulated. Thank you again for just being brilliant.
It's very sweet of you, James. Thank you.
+1.
But thank you.
So I should warn you, this stuff it's only just getting into the browser, right? So Firefox 39 will be public in 6 weeks' time. What? Today, did you say?
No, I said in 2 days, because I think they changed this. They do often releases, but it was more like
so you couldn't push it out today, but a month's time, you'd be reasonably safe, I think.
Well, for an engineer, at least what you try to do tomorrow would be interesting, because we anyhow run the latest versions in developer mode that measuring the round trip. So probably we don't mind running beta.
Right.
Yeah, so that's fine.
Come on, folks. You have questions about WebRTC, and you have the expert on stage. More questions.
Or find me at lunch. If you're shy, you know, that's fine.
You have his URL now, so you can find him at lunch and any time.
Yeah. Well, email, you know. Cool.
Email.
All right. Thank you.
Thank you. Sorry. Okay. Thank you, Tim. Thank you for coming. Appreciate it. Okay. So